from a successful ice fishing trip pulls a sled loaded with salmon. The total mass of the sled and salmon is 50 kg, and the man exerts a force of magnitude 1.2 times 10 to the power of 2 Newton on the sled by pulling on the rope. How much work does he do on the sled if the rope is horizontal to the ground and he pulls the sled 5 meters? How much work does he do on the sled if theta equals 30 degrees and he pulls the sled the same distance? At a coordinate position of 12.4 meters, the man lets up an applied force. A friction force of 45 Newton between the ice and the slate brings the slate to a rest at coordinate position of 18.2 meters. How much work does friction do on the slate?
Okay, right. Now, there are three cases. The first case is the force is not acting at an angle. The force is horizontal. It's not like this at an angle. Not like shown in the diagram there. Right? The theta here is 0. Okay. So how much is that force? Okay. When the man is pulling it, a magnitude of 1.2 times 10 to the power of 2. So it means that the horizontal force is 1.2 times 10 power is 120 newtons. So it's something like this, right? Okay. So the man is pulling horizontally with a force of 120 newton, and he moved through a distance of 5 meters. 120 newtons, 5 meters. Before I start using the formula FD, I try to check and see, is the force and the direction of the displacement, are they the same? Are they parallel? Oh yeah, this is moving here, and the distance, the horizontal displacement is the same direction. So I can multiply the two of them together to find the work done. Okay, so first one, the horizontal force is 1.2 times 10 to the power 2 Newton. The distance moved is 5 meters. Applying the formula, work done is F times D. Can apply or not? Parallel, can. So I multiply the two numbers together. I have 6.0 times 10 to the power of 2, 600 joule, or 600 Newton meter, right? So the unit is joule or Newton meter. The second case, how much work he do on the sled if theta equals to 30 degrees and he pull the same distance. Pull the same distance, in this case, pull the same distance in this case. This one is 5 meter. So in the second case, it's also 5 meter. But in the second case, he is pulling at an angle of 30 degrees. So the angle here is not horizontal, but the angle is 30.0 degrees. Equals. So the angle now is 30.0 degrees. It's not horizontal like this. So if this is the case, I cannot multiply the 120 newtons. The force is still the same, 120 newtons. The force is still the same, 120 newtons, but acting at an angle of 30 degrees with the horizontal. Now this time, because the force is not parallel to the distance moved, so I cannot use the 120 multiply with 5 meters. So if cannot multiply directly, I should find the horizontal component. The horizontal component is this one, F cos theta. So this F cos theta is in the same direction as the displacement. So I can multiply the F cos theta with the displacement. So how much is F cos theta? So I try to calculate F cos theta. So F cos theta is 120 cos 30. 120 multiplied by cos 30 is 103.9 newtons. 103.9 newtons. How much is the displacement? The distance moved through 5 meters. Correct. So now I can safely multiply these two. Why? Because they are parallel. So I multiply these two together. F cos 30 multiply with the D. So multiply, use your calculator. You multiply these two numbers together. It is 519.6. So the book round off to 5.2 times 10 to the power of 2 joule. Any questions so far?
No questions, sir.
No, the force must be parallel to the direction of the motion, direction of the displacement. Okay, the last problem. At a coordinate position of 12.4 meter, a man lets up on the applied force. A frictional force of 45 newtons between the ice and the sled brings the sled to rest at a coordinate position of 18.2 meters. How much work does friction do on the sled? Now it means like this. The man is pulling it along the surface of the ice. After moving to a position of 12.4 meter, he's very tired. So he let go of the rope. But when he let go of the rope, the load continued to move. Move until where? Move until 18.2 meters on its own, subjected to the friction of the ice. So now the ice produces kinetic friction, asking the load to stop, but it cannot stop immediately lah. After a certain distance, then it stops. The question now is, how much work is done by this frictional force to put the load to rest? How much work is used to stop the load from moving? The work done is by friction, not by the man. Okay, so we look at the diagram here. At the distance of 12.4 meters, the man let go of the rope. And there's a single force acting on the load, on the sled. That single force is the frictional force. It's a frictional force. And this frictional force cannot stop the load immediately. It allows the load to move until 18.2 meters. Then the load comes to a stop. Along this distance here, it is subjected to this frictional force. So how much work is done by the frictional force? Before we look at how much work is done by the frictional force, we want to know how much distance is covered. What is the horizontal displacement? Do you know how much is the horizontal displacement?
12.4
From 12.4 to 18.2.
5.8.
5.8. So you subtract. You take this final position minus the initial position. Then the distance between them is 5.8. So the distance moved by the load or the sled is 5.8. How much force is opposing it? It is the frictional force, 45 newtons. So this number is too near to the negative sign. So it's negative 45 newtons. Since the force and the distance, they are parallel, I can multiply them directly. I use 45 multiply with 5.8. Negative because it's going to the left. The force is to the left, so it's a negative. So negative 45 multiply with the distance traveled, 5.8. The answer is negative 216 joule. Any questions so far?